I'm so happy to see this lively crowd here today. And I'm also truly delighted to be able to introduce Rayla Temin as the anchor and the, if I may say, the highlight of our program today. We really thank her deeply for participating in the symposium and for sharing her memories and insights on some truly remarkable accomplishments and events. Now, as most of you know, Rayla is an emerita professor of genetics here at UW-Madison, celebrated both for her research and for her teaching. Rayla earned her PhD in genetics in Madison with Jim Crow, a legendary geneticist who was also renowned both for his research and his teaching. Rayla's research, first with Jim Crow and then in her independent career, frequently utilized Drosophila, and it addressed multiple fundamental genetic principles, such as the effects of recessive and partially dominant genes in viability and fitness in both homo and heterozygotes, and the mechanisms by which Drosophila segregation distortion locus drives dramatically unequal transmission of alleles and other principles. Even her very first paper as a graduate student, which was comparing the effects of lethal and detrimental chromosomes in Drosophila populations, was highlighted then and in later retrospectives as a landmark publication in population genetics. Now, in parallel with this research, Rayla's teaching enriched decades of students, reaching at least 3,000 students just through her teaching of the introductory genetics course alone. Rayla's graduate studies here were punctuated by a very productive year in Edinburgh with Charlotte Auerbach, the discoverer of chemical mutagenesis. And it was upon Rayla's return to Madison that she met Howard, and thus began a beautiful partnership that led to their joint professional and family success. And from the unique perspective of that partnership, we thank her again for sharing some of her insights about Howard, his work, and their family. Rayla.
Thank you for this opportunity to remember Howard. While I cannot present the talk that Howard would have given or undertake a review of his scientific opus, I'd like to offer in pictures and on occasion in Howard's own words a few of the signal moments in the life of this caring and courageous man. From his formative years to his work on viruses and cancer, his perseverance in pursuing evidence for an unorthodox idea, and the ensuing recognition of his path-breaking discovery. I'll say a bit about his continued contributions to science and his dedication to global issues, and finally, his legacies. Howard was born in Philadelphia on December 10, 1934, the middle of three brothers. In school, he assumed leadership roles from an early age. Here he is in 8th grade. As editor of his school paper, Howard took up many causes here on charity, exhorting his classmates to give from their own savings to help hungry or sick or uncared for people. Howard's activism for the public good and social justice was a pattern followed throughout his life. These early quotes are from a scrapbook kept by Howard's mother, Annette Temin. During high school, Howard attended the then-fledgling summer program at the renowned Jackson Lab in Bar Harbor, Maine, in 1950 and 1951. He credited that experience to be formative in directing him into biology. In a newspaper interview, he enthused, as you see here, "Most of our time is spent working, and that is really my favorite pastime. Now, more than ever, I plan to go into science myself. I'm enjoying the experience tremendously. I've never done any of this kind of science, actual research, before. In fact, some of the work we're doing has never been done by anyone before. We have lots of group fun combined with scientific thrills." Howard returned to the Jackson Lab in 1955 as a counselor for the high school students. Here he is with one of those students, David Baltimore, who grew into the eminent scientist awarded the Nobel Prize in 1975 along with Howard. This is when they first met. David later described Howard as the guru at Bar Harbor. We were so saddened this week by the news that David died just this past Saturday. We will be thinking of David during the course of the talks today and remembering him. Here they are in the photo of the class of 1955 from the Jackson Lab archives, with David Baltimore is in the top row in the middle, and Howard is off to the side. Howard attended Swarthmore College from 1951 to 55, majoring in biology. The courses were of the classical mode, but Howard yearned for molecular biology, a field then newly emerging with the excitement of the 1953 discovery of the structure of DNA and the ensuing studies of the flow of genetic information from DNA, the blueprint, into RNA, then translated into protein. In contemplating a career path, Howard wrote, as you see, that he would like to set up and run an experiment. Nature supplies the answers. If unsuccessful, it's up to me, he reflected, because nature would always answer well-designed experiments. This could not have been more prescient. Howard attended graduate school at Caltech with its historic and burgeoning activity in genetics and bacteriophage, or known as phage. These are viruses that infect bacteria, and indeed in molecular biology. Howard lived in a big house across the street from the lab, along with Messelson and Stahl. At the time, they were doing their famous experiments on DNA replication, which they discussed at every dinner, a heady and stimulating intellectual atmosphere for a grad student. At Caltech, the research with phage was led by Max Delbruck, the illustrious founder of the phage group. This included discussion about a still mysterious stage in the life cycle of certain phages where they integrate into the chromosome of the bacterial host as a prophage and travel along with it, as was being elucidated by André Leboeuf. This was at least conceptually possible because these phages are made of DNA, as is the host bacterial chromosome. Here is Howard as a grad student at Caltech. He's showing some cells to a very eminent visitor to the lab, Boris Efrusi, who came from the Sorbonne. Howard's major professor at Caltech was Renato Delbecco, a founder of the newer field of animal viruses, with whom Howard received his PhD in 1959. It was as Delbecco's grad student that Howard embarked on his research with Rous sarcoma virus, RSV, that causes cancer in chickens. The phage viruses cited earlier are made of DNA, as noted, but there are viruses, some of which have RNA as their genetic blueprint, and RSV is one of those RNA-bearing viruses. Howard made some unexpected observations based largely on quantitative studies of virus replication and genetics that led him to the notion that RSV adds to the cell genome information that turns it into a tumor cell. Being steeped in the lore of the phage work, Howard called this proposed information-bearing structure a provirus. In 1960, he posited, as quoted here, that from a functional point of view, there's little difference between chromosomal or gene mutation and infection by Rous sarcoma virus. Both sets of events cause genetic changes in the cell. The virus, in some structural as well as functional sense, becomes part of the genome of the cell, he wrote. But the tricky part of this was how could an RNA virus act like a DNA gene in becoming a stable and permanent part of the heredity of its host cell? No way was known at that time. Howard pursued the nature of the provirus as he moved to Madison in 1960, joining the faculty of the McCardle Lab at the University of Wisconsin, shown here with Howard in the upper left. He's the only one of the gentlemen who's not wearing a jacket. Howard and I met here at the UW in 1961 while I was a graduate student with Professor James Crow in the Drosophila Genetics Lab. Howard and I married in May 1962, and we raised our daughters, Sarah and Miriam, in Madison, where we enjoyed a close family life. Right after we married, Howard went to Cold Spring Harbor Biological Lab to speak at the June 1962 Symposium on Basic Mechanisms in Animal Virus Biology. Howard's paper on morphological conversion and virus production lent support to the provirus hypothesis, where he wrote, as you see here, "It appears that a common mechanism in tumor formation by RSV could be the presence of the viral genome at a specific site in the cell, causing conversion and carcinogenesis. Conversion means that when this virus infects cells in cell culture, it causes a change in the shape of the cell, from flat to round cells, a discovery that had been made earlier. And this change in morphology in the cells observed in the lab was thought to echo the ability of the virus to cause tumors in chickens. Further, Howard found another RSV strain that produced an inherited variant morphology in converted chicken cells, from flat cells to long fusiform cells, further strengthening the genetic hypothesis. Here, Howard is visiting, seated on the lawn, with, again, Boris Rafrusi and Giuseppe Attardi. Based on experiments carried out in his basement lab in McCardle, Howard presented evidence in 1963 that the provirus was DNA. He proposed the revolutionary hypothesis that the RNA virus directs the formation of a DNA copy of itself, which then becomes part of the chromosomal master blueprint of the cell. And then progeny RNA viruses are produced from that. In his paper, The Effects of Actinomycin D on Growth of RSV in Vitro, where actinomycin is an antibiotic and chemotherapeutic drug that interacts specifically with DNA, he wrote, "Since the effect of actinomycin depends upon interaction with DNA, the effect on RSV production is probably mediated through DNA. It appears that the treatment prevents formation of viral RNA. Therefore, it is suggested that the template responsible for synthesis of viral nucleic acid is DNA or located on DNA. I'll come back to this 1993 paper later. Howard published up to 20 papers on this topic, mostly as the sole author, but his unorthodox idea was essentially ignored, if not derided, running counter to the central dogma pertaining to flow of genetic information from DNA transcribed into RNA. Howard was proposing that genetic information could flow in the reverse direction. Howard did point out that although his proposal was not taken too seriously outside UW, where he received a lot of support here, he did have ample grant support throughout from the NIH. Amidst the turbulent 60s, Howard continued to carry out experiments to test his provirus hypothesis, culminating in 1970 with the clinching biochemical discovery of the special RNA-directed DNA polymerase in the virions of RSV. In Howard's words in a later interview, he said, "Although I'd reported the experiments in support of my proposal earlier, the evidence that proved my hypothesis to most scientists was the discovery of an enzyme in some RNA tumor viruses that were using RNA as a template for making DNA. The enzyme was first discovered in the spring of 1970 by Dr. Satoshi Mizutani in my lab, and at the same time independently by David Baltimore at MIT. Howard announced the discovery in May 1970 at the 10th International Cancer Congress in Houston. The discovery of the enzyme, named reverse transcriptase, was riveting and led to an explosion in research on retroviruses, RNA viruses that used reverse transcriptase. Howard's work on viruses and cancer built, of course, on foundations laid down by others. I mentioned the prophage and Andrei Lvov, the work at Caltech, the early discovery by Rouse of Rouse sarcoma virus and the descriptions thereof, and other. Having taught undergraduate genetics for many years, I could not help but think of Gregor Mendel and how Howard followed in his footsteps as well. Mendel had round and wrinkled peas. Howard had round or fusiform cells following infection with RSV in cell culture. Mendel's most fundamental contribution was to replace the prevailing blending theory of inheritance with the particulate theory. Mendel came up with the idea of the gene as a hypothetical entity that could make sense of his plant breeding experiments. This was, even though the underlying physical, or indeed molecular, vehicles of inheritance were not yet described. And Mendel counted his peas. His great discovery depended on numbers and ratios in an era when it was not appreciated that you could study biological processes by quantitative methods. In 1866, Mendel, of course, was way ahead of his time, his work ignored until the rediscovery in 1900. Howard, likewise the careful experimentalist, also listened to what nature was telling him. He'd proposed the provirus initially as a state of the viral genome, a genetic concept without implications as to its molecular or physical nature at first. That was soon to follow. Howard, too, established a precise quantitative approach. An early contribution of his was to develop a quantitative focus assay that became a standard tool for genetic studies of transforming viruses in cell culture. Thus, in looking for the key to how certain RNA viruses could convert a cell into a tumor cell, Howard discovered a new and fundamental secret in biology. Like Mendel, Howard acquired an ism. The term Teminism, the idea that DNA can be synthesized from an RNA template, first appeared in the journal Nature in a report of that May 1970 meeting that spotlighted Howard's talk, saying, "During 8 hot days in Houston at the 10th International Cancer Congress, Temin will have established how the genetic information in RSV could be stably inherited. Certainly, the time is right for putting Teminism to an acid test." Soon after, Teminism expanded from an idea to an activity. Here is advice for Teminizers. Teminism, the activity triggered by Temin's discovery that RNA tumor viruses can reverse the normal direction of flow of genetic information by acting as templates for the synthesis of DNA, is booming. Now, many years later, when it became possible to Google things, I Googled the term Teminism. And unbelievably, I got tens of thousands of hits. But it seemed that the Google master thought I had misspelled, and they gave me tens of thousands of feminism. And Howard was indeed a very strong supporter of women, but that was an interesting glitch there. Further, in fishing for viruses and cancer cells, the evidence in favor of Teminism continues to mount apace. Temin's image has transformed from that of a stubborn crank to persistent visionary. Howard's work captured attention beyond the world of science. Here in 1971, he is featured on the cover of Newsweek in connection with the launch of Nixon's War on Cancer. Now, pay attention to the vial that Howard is holding up to the light there. You'll hear more about that in a later talk. In 1975, together with David Baltimore and Renato Del Becco, Howard was awarded the Nobel Prize in Physiology or Medicine. Howard was adamant that the Nobel Prize not take over his life. He was determined to carry on just the same as before. Even on the very day the Nobel was announced, even with all the excitement, we sent our young daughters to school, and Howard biked into work as usual, although on that day pursued by journalists. He let them take photos around him as he followed his daily routine, starting out at his microscope, looking at cells amidst the celebratory activity in the lab. His student, Sandy Weller, is likewise carrying on with her regular work. Sandy may give you her version of that day in her talk later. Our family traveled to Stockholm, where Howard received the Nobel Prize on the very day of his 41st birthday, December 10th, 1975. On the evening of the prize ceremony, there was a splendid banquet in the majestic Stockholm City Hall, with 1,200 guests in attendance. In other scenes from Nobel Day, here is David Baltimore helping Howard with his tie. In the other picture, Howard, when he had the ear of the king, when the king shakes the hand of the laureate and hands them the medal, Howard knew he'd have an opportunity to speak directly to the king, and what he chose to do on that day was to request a private audience with our family. And we were granted that private audience with King Carl Gustaf of Sweden. Howard hoped to use the prestige of the Nobel to bring attention to vital causes, and he took the opportunity to do so even at this very occasion. At the banquet, Howard ascended the podium to give the brief response on behalf of their trio of laureates. Your Majesties, your Royal Highnesses, fellow laureates, ladies and gentlemen, Renato Del Becco, David Baltimore, and I thank you for the great honor you have given us. However, we also realize that our work has not yet led to prevention or curing of human cancer. We are in fact outraged that the one major measure available to prevent much cancer, namely the cessation of cigarette smoking, has not been more widely adopted, as may be noted at the table where I'm sitting behind that table decoration. Now, this was very daring, and I can tell you from being at the table that people just gasped that he would say that. And it was very daring, considering that the king and the prince and the princesses and many of the royalty and 1,200 guests were smoking. Howard continued to be an impassioned and outspoken educator and lobbyist concerning the dangers of smoking to human health. In the years following the Nobel Prize, Howard kept his laboratory small and his research program very much alive. He maintained close consultations with students and postdocs, colleagues, and friends. He continued his bench work and his mentoring and teaching the general virology course with Bill McLean, 30 years in all, as well as doing other teaching. Further, Howard felt a responsibility and desire to apply his science for the public good. His thoughtful advice was sought in many domains. In those ways, the Nobel did, in fact, change his life. And so communication was an important part of Howard's day. Directly upon returning from Stockholm in January of 1976, Howard requested an upgrade in the prevailing technology in a letter to the appropriately named Mr. Toner. I would like to request, he wrote, a touch dial phone. Because I do not have a secretary immediately adjacent to me, I dial many of my calls. This phone will make it easier. A copy was sent to UW Chancellor Edwin Young, and this high-tech requisition was soon filled. Along with his advocacy in science and major public health issues, Howard dedicated himself to worthwhile causes around the globe. Here are but two of many such journeys. This is not to be read here, I'll just summarize. In 1976, Howard traveled to the Soviet Union at the invitation of the Academy of Medical Sciences there. In addition to official visits to laboratories, he sought out refuseniks, that is, Soviet Jews who were refused permission to emigrate, and also dissidents, using names and addresses he had obtained from the Committee of Concerned Scientists here in the US. Armed with pocket flashlight to cite apartment numbers in the dark, and a small camera and tape recorder, Howard set forth from Madison with trepidation because he was bringing in Hebrew books plus articles from Science and Nature, which were not allowed into the Soviet Union at that time. After his official daytime lectures, he sometimes would even skip dinner. He would embark on his unofficial itinerary, sneaking away in the dark, showing to some taxi driver the addresses he had rewritten in Cyrillic. He also attended the clandestine Sunday seminar, the secret gathering of scientists. He arranged other private meetings, one, for example, with Andrei Sakharov. Sakharov was a fellow laureate in 1975, in fact, but he was not allowed to leave the Soviet Union to receive his Nobel Peace Prize. Howard, in his article, Moscow Diary, Human Rights, describes his often chilling experiences during the double life he led on that trip. He took very big risks, not only going in and during the visit, but when he left as well, smuggling out messages and illicit materials by refuseniks and photos he had taken and tapes. After he came back, he shared his experiences widely and pressed the cause of dissidents during that perilous era. In 1977, Howard traveled to China as the research scientist member of an economic trade group from Wisconsin led by Governor Patrick Lucey to the People's Republic. This was one of just a handful of missions admitted to China at that time. Along with official tours, Howard visited and lectured at many biological and medical institutes. He provided his appraisal and technical summaries of education and science, including the research on liver and nasopharyngeal cancers so common in China. Howard's informed and detailed reports were among the earliest of that genre available after the opening of China to the West. Howard regularly helped out at the state level, too, with issues at the university and its interface with the government and legislators, so essential at our public university. Here he is with Governor Anthony Earl in 1984. During a budgetary crunch for the state of Wisconsin, amidst concerns at the UW that this would impact the quality of the faculty, Howard invited Governor Earl to his lab. By demonstrating personally how research and mentoring are carried out, Howard hoped to provide information that the governor could use to strengthen the university. Here is Howard at the Cold Spring Harbor Lab in 1990, celebrating 20 years of reverse transcribing at the RNA tumor virus meeting at that time. Yang Kang and John Coffin, formerly in Howard's research group, are looking on as Howard cuts the appropriately decorated cake. In the years leading up to this, Howard continued his research, for example, on the formation of retroviral DNA and its integration with cell DNA. He pursued basic problems on the structure, variation, mutation, and replication of retroviruses. He worked on retroviral vectors for gene transfer and possible gene therapy. He thought about the origin and evolution of retroviruses and the role of reverse transcription on the structure of the human genome and other related subjects. And you will be hearing about these in more detail during the talks today. Importantly, the foundational work on retroviruses and reverse transcriptase set the stage for the discovery that the pathogenic human retrovirus HIV was the cause of AIDS. Howard devoted a great deal of his efforts to guide policy decisions regarding AIDS and to promote and support research on HIV, including being on the committee to name the virus with the neutral name human immunodeficiency virus. He served on many related committees, national and international. He was often called upon to settle major disputes and also to teach about HIV/AIDS and to bring attention to the urgency of the epidemic. For him, this was a mission. In the early 1990s, Howard started work on an approach to a possible AIDS vaccine. In June of 1992, Howard was awarded the National Medal of Science. Our family went to the White House. And again, Howard knew he'd have just maybe a minute or less to have the ear of the President of the United States. So at that moment, when he had the ear of President George H.W. Bush, Howard used the occasion to appeal for increased funding for basic research. What better example could there be of the unexpected applications of basic research than those emanating from Howard's early curiosity about how certain rare viruses can cause cancer in chickens? How was it that a tiny virus with so few genes could bring about such monumental changes in a cell? It could not have been predicted, for example, that an enzyme would be discovered that would provide vital material for genetic engineering and biotechnology, or that the knowledge of the replication patterns of HIV could lead to antiretroviral agents that work by targeting that enzyme, reverse transcriptase, or that the widely used PCR test to detect the presence of the coronavirus causing COVID-19 includes a step using reverse transcriptase. It was later that summer of 1992 that Howard was diagnosed with the cancer that took his life. He continued working as much as possible during his treatments, even until December of 1993, when he escorted his student, Xiaolon Yang, at graduation when she received her PhD. Also, during 1993, in October, Howard presented his research on the genetics of retroviruses at the conference in Chicago celebrating DNA, Double Helix 40 years. Here's Howard with Jim Watson and others. Also, in that year, 1993, there was a retrovirus meeting at Cold Spring Harbor Lab. That is what I was alluding to earlier about this anniversary. The program book featured Howard's 1963 actinomycin paper on its 30th anniversary. Howard was unable to attend, but he treasured the program book that was inscribed by many of the participants and presented to him. A few of the numerous heartfelt inscriptions in the book are shown here. So up there in the right-hand corner, there's an inscription that says, "Dear Howard, please come back. I'm tired of asking your questions, John Coffin." Howard had so many interests. He was a voracious reader and built an extensive library. He loved his garden, and he enjoyed the Chinese scroll paintings he brought back from the PRC. He liked to go to concerts. These all provided for relaxation and contemplation. Sometimes at a concert, he'd pull out a little notepad from his jacket pocket and jot down an idea for an experiment. Howard loved nature and the outdoors, and depending on the season, he biked or walked, briskly of course, to and from his lab daily along the beloved UW Lakeshore path along Lake Mendota. In winter, he walked no matter how frigid the weather, bundling up in his down coat and pushing through, even in some blizzards. In recognition of Howard's many contributions to the UW and what was said to be his symbiosis with the path, this beautiful wooded lakeshore path was dedicated to Howard in 1998, and it was renamed for him. And I just want to say as aside, this was proposed, this idea of renaming the path was proposed to the university by Howard's and our friend Frank Turkheimer, and it had to go all the way up to the regents, but they did rename it, and then there was a lovely ceremony. There are bronze historical markers at each end of the path. I'll read just a little bit of it where it says, Howard was an exceptional seeker of truth in science and responsibility in society. And then down at the bottom, throughout the seasons, throughout the years, Dr. Temin walked and biked on this path, appreciating its beauty and finding enrichment in its setting and wildlife. Above all, and at the core, Howard was devoted to his family. His legacy is carried forward by our daughters, Sarah and Miriam Temin, whose interests have taken them into professions close to Howard's heart, and also by Miriam's son, Micah H. Temin. Sarah works at ASCO, the American Society of Clinical Oncology. She works with ASCO members to develop and disseminate evidence-based clinical oncology guidelines. Her working group publishes its updated guidelines in the journals represented here, and this shows their recent guidelines, the first one on palliative care for patients with cancer, and the other one is a systemic treatment of patients with metastatic breast cancer. Miriam's area is international public health, now known as global health, including reproductive health and HIV/AIDS. Miriam has worked in Africa, especially Zimbabwe, Senegal, and elsewhere in West Africa. Based in New York City, Miriam worked at UNICEF and with the Center for Global Development, and she has been for a number of years at the Population Council. She is a senior associate there with a specialty in using evidence to improve programming for adolescent girls globally. As you see, to implement programming for adolescent girls globally and to implement HIV prevention, as discussed in the papers cited here. Howard's grandson, Micah, is a participant in his high school independent science research program. In the summers and during the academic year after school, Micah heads over to the NYU Langone Medical School to the cell biology lab of Professor Jessica Treisman, who is studying the visual system of Drosophila. One of the lab projects is focused on a mutation of the corneal lens in which the normally curved lens becomes flat. Micah is taking part in identifying genes that control corneal lens curvature, as outlined in the poster he presented at a symposium at his high school this spring. My family are here with us today, and I'm sure would be happy to talk with you about their work and other matters. Howard also lives on through the work of his many scientific children, as he used to say, represented by the speakers who you will be hearing from today. Thank you.